Financial misconduct no longer hides in paper ledgers. Irregularities move through digital systems, cloud platforms, and fragmented databases. Organizations generate far more data than any human team can examine manually with sufficient depth and speed. Investigators have no choice but to adopt automated tools. Artificial intelligence operates on probability, not certainty. It produces outputs based on statistical likelihood and learned pattern inference. It estimates whether a transaction resembles known irregularities. This creates an immediate conflict with the rules of forensic accounting. In an investigation, a finding must be an exact, verifiable fact. A reconciliation either matches or it does not. Courts, regulators, and enforcement teams reject probabilistic assumptions. They demand strict logic, clear source records, and an unbroken chain of custody. If a test is run today, it must produce the exact same result tomorrow. Relying on raw AI output to find fraud turns a legally binding investigation into an unverifiable statistical guess. A generated risk score might look convincing, but it lacks factual grounding. When investigators feed financial records directly into generative AI models, they trigger two severe operational risks. The first is hallucination. Because AI relies on statistical patterns rather than verified databases, it can fabricate plausible but entirely fake regulatory references or invent transaction explanations that never actually occurred. The second is a breach of confidentiality. Uploading sensitive payroll details, vendor identities, or unredacted legal communications to external cloud servers exposes an organization to immediate legal liability. To use AI safely, investigators must strictly separate logic generation from data execution. This relies on a secure triad workflow. Artificial intelligence generates the analytical logic, Excel VBA executes that logic locally on the data, and Power BI visualizes the results for review. This decoupled architecture allows the investigator to leverage the speed of machine learning while keeping sensitive data under local control. The first step in this triad requires stripping the AI of its creative variability. We force it to function strictly as a coding and logic assistant. By default, large language models produce different responses to the exact same prompt. In an audit environment, this inconsistency destroys reproducibility. We control this by turning down the temperature setting. As the value approaches zero, the randomness of the model collapses into a single stable point. A near-zero temperature setting ensures the AI will draft stable, highly reproducible analytical roles and code. The second constraint is a domain knowledge base. By feeding the AI specific official documents, like international financial reporting standards and internal organizational policies, we force the model to use correct industry terminology and logic. Constraining the model prevents it from inventing generalized investigative rules. It locks the outputs to strict professional and legal standards. Next, we establish the operational air gap. The investigator can communicate with the AI, but the actual evidence cannot. Investigators use abstracted prompting. They describe the file structure, the analytical goal, but never the sensitive contents. An investigator requests code using generic headers like vendor, invoice, amount, and approver. Sensitive transaction values never cross this firewall. They remain hidden. In return, the AI provides a structured script, not a finding, risk score, or verdict. This abstraction process fulfills data protection mandates while securing advanced analytical code in seconds. This brings us to Excel VBA. In forensic work, VBA functions as a secure, deterministic local execution engine. Executing code locally provides a structural defense. The AI-generated code runs exclusively on the investigator's machine, meaning the evidence never leaves the organization's control. We can see this engine at work through threshold split analysis. Fraudsters divide large payments into smaller invoices to stay safely below a manager's approval limit. The VBA loop groups these transactions by supplier and date, immediately catching the combined threshold breach. Unlike probabilistic AI guesswork, this rules-based loop executes the exact same mathematical test every single time. This deterministic process provides reproducibility, allowing a court or an auditor to replicate the exact finding later. As the procedure runs, the VBA script automatically generates an unalterable audit trail and processing log, documenting every file loaded and every validation check performed. During this entire data sweep, the evidence remains within the protected internal environment. VBA transforms messy, raw records into defensible, verifiable evidence, bridging the gap between advanced automation and data security. Massive lists of flagged rows make it difficult to grasp the operational scale of an irregularity. Power BI acts as the visual surface of our triad. We use it to interpret the deterministic exceptions generated by VBA. Mapping these exceptions visually instantly highlights behavioral timing, such as month-end earnings management or unusual vendor concentrations. Recognizing a visual anomaly takes seconds, bypassing the manual effort required to read through hundreds of raw code outputs. The dashboard does not prove fraud. It translates complex data into a narrative structure that human reviewers can investigate further. This is the structure of the modern forensic workflow, from the initial prompt to the final human review. This system operates against a strict boundary. Technology is limited to detecting the anomaly. A flagged transaction is an exception, not proof. A duplicate invoice is often just a clerical error. Human professional skepticism enters here as the indispensable final stage of the workflow. Only a human can synthesize the financial anomaly with external behavioral context, motive, and documentation quality to prove actual intent. The role of the forensic accountant is evolving as automation becomes more accessible. Effective forensic work now requires the ability to use technology to enforce discipline, ensuring that automation supports rather than replaces professional judgment. While machine automation scales the volume of data we can process, human accountability remains the requirement for every finding presented in an investigation.